Hello friends, Mr. Burrell here. We just finished talking about set notation, kind of how to identify sets of values, sets of numbers, sets of elements, and now we're going to talk about that in relation to probability. So again, this whole unit is on probability, so we're going to talk about set theory, set notation, and probability kind of in tandem. We're going to use them together. So by the end of this video, this is what I hope that you're able to do. I want you to be able to find the probability of an event happening in both fraction, decimal, and percentage form. And I'll talk about that as we get into this. And I want you to be able to find probabilities of events given in set notation. So in the last video, we talked about intersections, unions, complements, things like that. We're going to be able to find the probabilities of events, of situations given in set notation, and we'll talk about that here. So again, now that we've discussed set notation, let's talk a little bit more about probability, what it means. We kind of defined it briefly at the beginning of the last lesson. But probability, again, is how likely it is for an event to occur. How likely is it that it's going to rain tomorrow? How likely is it that I'm going to draw a certain card out of a deck of cards? How likely is it for me to roll a 1 on a 6-sided die? How likely is it for me to roll a 1 on a 20-sided die, etc., etc., etc.? That's what we're talking about when we talk about probability. So mathematically, we define probability as the following. So the probability of an event happening is the number of ways it can happen divided by the total number of possible outcomes. So for example, let me really briefly, if I am rolling a 6-sided die here, here's my 6-sided die, does not look good. If I roll a 6-sided die, and I have 1, 2, whatever, you know. If I roll a 6-sided die, and I want to know what is the probability that I roll a 1? What is the probability that I roll a 1 on a 6-sided die? Well, how many ways can I roll a 1 on a 6-sided die? Well, there's only one 1 on a 6-sided die. So I have 1 in the top of my fraction. What's the total number of possible outcomes? How many possible different numbers could I roll when I roll a 6-sided die? Well, there's a 1, 2, 3, 4, 5, 6, because there's 6 sides on a 6-sided die, so there's 6 possible numbers I could roll. So the probability of rolling a 1 is 1 out of 6. As a fraction, that's 1/6. If I take 1 divided by 6 in my calculator, that's 0.166 or 0.167. And then as a percent, if I were to write that as a percentage, I move this decimal over 2 places, multiply it by 100, and I get 16.7%. So there's a 1 in 6 chance of me rolling a 1, or there's a 16.7% chance of me rolling a 1 in a 6-sided dice. That's what we're talking about when we're talking about probability. This might not be terribly new information for you, but I think it's good to review. So when we're starting to talk about probability, let's remind ourselves of a couple terms and definitions. A sample space is the set of all possible outcomes. We talked about sample spaces when we were talking about set notation. So the sample space is the set of all possible outcomes. The sample size is the total number of possible outcomes. Previously, when I just did the 6-sided die, the set of all possible outcomes would be 1, 2, 3, 4, 5, and 6. Those are all the possible numbers that I can roll. The sample size would be 6. There's 6 total options, 6 total possibilities for what I could roll on a 6-sided dice. So let's look at the example of drawing a card from a deck of cards. So what would be the sample space for drawing a card from a deck of cards? Well, here are all the possibilities, all the possible cards in a deck of cards if I subtract the jokers. I have ace, 2, 3, 4, all the way through 10, and then jack, queen, and king. In hearts, diamonds, spades, and clubs. That's my sample space. So what is the sample size? Well, the sample size would be 52 because there are 52 total possible cards you could draw. There's 4 different suits, and then there's 13, 1 through 10, and then 11, 12, and 13. 13 times 4 is 52. There are 52 possible cards that you can pull from in a standard deck of cards. Okay, so now we're going to start talking a little bit about probability. So remember that probability of an event happening is the number of ways it can happen divided by the total number of outcomes. So for example, this first problem says P and then parentheses 3 of hearts. So when I see something in this type of notation, let me move my face out of the way real quick. When I see something in this kind of notation, P parentheses 3 of hearts, I read that as the probability of drawing a 3 of hearts. That's what the P means, is a probability. So what is the probability of drawing a 3 of hearts? Okay, well, the probability of drawing a 3 of hearts is going to be the number of ways I can draw a 3 of hearts divided by the total number of possible outcomes. So let's see, there's only one 3 of hearts in the entire deck of cards. So the number of ways I could draw a 3 of hearts is 1, divided by the total number of outcomes. The total number of outcomes is 52. So the probability of drawing a 3 of hearts is 1 out of 52. If I divide that in my calculator, I get 0.019. And then if I write that as a percentage, moving this decimal over 2 places, I get 1.9%. So I want you to be able to write the probability in all 3 of these ways, as a fraction, as a decimal, and as a percentage. So there's a 1 in 52 chance of drawing a 3 of hearts out of this deck, or a 1.9% chance. Okay, what's the probability of drawing a jack? Okay, so the probability, I'm looking for all the number of ways that I could draw a jack. Well, I have a jack of hearts, jack of diamonds, jack of spades, jack of clubs. So there's 4 jacks, divided by a total of 52 cards. So my probability is 4 out of 52. I could reduce that fraction to 1 out of 13. Either of these would really be fine. If you were taking the ACT, it would probably be in reduced fraction form. But there's a 4 in 52 chance, or a 1 in 13 chance of drawing a jack from this deck of cards. If I write that as a decimal, it's 0.077, or 7.7%. So those are the 3 ways I want you to be able to draw these probabilities. Okay, what about the probability of drawing a diamond? Well, here are all my diamonds. There are 13 of them. So the probability of drawing a diamond would be 13 divided by 52. If I write that as a simplified fraction, which you don't have to necessarily on your homework, but as a simplified fraction that you'd see on the ACT, that would be 1/4. 1 divided by 4 is 0.25, or 25%. So there's a 25% chance that you're going to draw a diamond out of the deck of cards. Okay, what about the probability of drawing an even number? Well, 2, 4, 6, 8, and 10 are all even numbers. So let's see, that's 4, 8, 12, 16, 20. So there's 20 possible ways that that can happen, divided by a total of 52 cards. 20 divided by 52, if I write that as a reduced fraction, which again, you don't necessarily need to for your homework, that would be 5 out of 13. So 5 out of 13, that's the chances of drawing an even number out of this deck of cards. 5 divided by 13 written as a decimal would be 0.385, and as a percentage would be 38.5%. That's the probability of drawing an even number. I'll do one more example here. The probability of drawing a face card. If you don't know what a face card is, that means one of these with a face on it, so a jack, a queen, or a king. So there are 3, 6, 9, 12 face cards out of a total of 52 in my deck. So there's a 12 in 52 chance of drawing a face card. If I write that as a fraction, that's 3 out of 13. So both of these numbers are divisible by 4. I divide them both by 4. And 3 divided by 13 written as a decimal is 0.231. As a percentage, that's 23.1%. I'm doing all these. I just have my calculator handy. You can do those numbers in your phone calculator on Desmos, or if you have an actual calculator at home, whatever. But that's what we're talking about when we're talking about probability. We're taking the number of ways something can happen divided by the total number of outcomes. Okay, let's sneak on over here. So now we're going to do a little bit more combining what we've talked about with probability with what we previously talked about with set notation. So this says use the following sets for the following questions. The sample space is the numbers 1 through 20. So write out the sample space here. My sample space is going to be 1, 2, 3, 4, 5, 6, 7, blah, 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 17, 18, 19, 20. That's my sample space. Set D is the set of odd numbers. So the set of odd numbers would be 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. Set E is a set of even numbers, so that's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. The reason I'm not going past 20, again, is because my sample space only goes up to 20. Set F is the multiples of 5 less than 21, so that's going to be 5, 10, 15, and 20. The set of all multiples of 4 less than 21, so set G is going to be 4, 8, 12, 16, 20. So I have my sets D, E, F, and G, and my sample space. Okay. So this says, what is P parentheses D? Or what is the probability of D? So the probability of D, again, if I go back here real quick, the probability of an event happening is the number of ways it can happen divided by the total number of possible outcomes. So basically I'm saying if I have a big tub with the numbers 1 through 20 in there, because that's my sample space, if I have a big tub with all 20 of my possible sample space numbers, what is the probability that I draw an odd number? Well, how many odd numbers are there? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 odd numbers. So the probability of set D, or drawing a number that is in set D, is 10 because there's 10 numbers in set D, divided by 20 because there are 20 total possible outcomes. 10 divided by 20 can reduce to 1/2, which is 0.5 or 50%. So the probability of drawing an odd number out of a pool of the numbers 1 through 20 is 50%, because 50% of the numbers are odd numbers. Okay, what is the probability of G? Well, G, the probability of G, how many numbers are there in set G? Well, there's 1, 2, 3, 4, 5. So there's 5 possible ways of drawing a number in set G, and there's 20 possible outcomes because I have a sample space of 20. That's how many numbers are in my little pool here. So 5 divided by 20, if I write that as a simplified fraction, is 1/4. As a decimal, 1 divided by 4 is 0.25, or 25%. So there's a 25% chance of drawing a multiple of 4, or a number from set G. Okay, so now I have here, what is the probability of G union F? So what is the probability of set G unioned with set F? So reflecting back to what we talked about with set notation, what does union mean? Well, union is all of the numbers in either set G or set F. So let's list all the numbers in set G or in set F. Well, there's a 4, a 5, an 8, a 10, a 12, a 15, a 16, and a 20. There's 20 in both of them, but I'm only going to write it once because that's kind of redundant. So the probability of G union F, going back here again, the number of ways that can happen, the number of elements in this set, there's 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 possible ways that I could draw a number out of the pool of G union F, divided by a total of 20 numbers in my sample space. So we're kind of combining what we talked about with set notation with what we're talking about with probability. So the probability of G union F is 8 divided by 20. If I were to write that as a reduced fraction, I believe that's 2/5. 8 divided by 20, or 2 divided by 5, is 0.4. If I move that decimal over 2 places, that means my percent is 40%. So the probability from drawing a number from set F or set G is 2 out of 5, or 40%. Last year, number 13 says, what is the probability of E intersect G. So here's set E, here's set G. So the probability of E intersect G. Well, E intersect G means all the elements that are in both set E and set G. So let's list all those elements. Let's see, set E, I have a 4 in both of these sets. I have an 8 in both of these sets. I have a 12 in both of these sets, a 16 in both of these sets, and a 20 in both of these sets. So 4, 8, 12, 16, 20. So there are 1, 2, 3, 4, 5 total possible numbers in in set E and in set G in that intersection out of a total of 20 possible outcomes. So 5 divided by 20 as a fraction, I can write that as 1/4, just like I did up here, 5 divided by 20, 0.25 or 25%. So there's a 25% chance that out of my pool of numbers between 1 and 20, that I would draw a number that is an even number and a number that's a multiple of 4. Okay, so that's what we're talking about when we're talking about probability and combining what we've talked about with probability with set notation. Okay, so that's kind of the meat and potatoes of this lesson, talking about probability. The big thing to remember, let me go back here, the big thing to remember is that the probability of an event happening is the number of ways it can happen divided by the total number of outcomes. That's how we define a probability. So let's, now I want to do a couple of the questions off of your homework assignment to kind of give you a head start on that. So these are questions 12 through 15, I believe. It says, use flipping 2 coins for the following questions. Let T be tails and H be heads. So what is the sample space for flipping 2 coins? So what are all the possible outcomes I could get when I flip 2 coins? Well, to help me with this, and you see some other problems kind of like this on your homework, to help me with this, I'm going to draw this little table. So here's coin number 1, here's coin number 2. So I could roll a head with coin number 1 and a head with coin number 2. I could roll a tails with coin number 1 and a head with coin number 2. I could roll or flip, whatever, a head with coin number 1 and a tails with coin number 2. And I could roll a tails with coin number 1 and a tails with coin number 2. Those are all the possible outcomes for flipping 2 coins. So my sample space, I could roll 2 heads, I could roll a tail and then a head, I could roll a head and then a tail, and then I could do a tail and then a tail. I keep saying roll, maybe I should say flip. Do you flip coins? Do you roll coins? Who cares? I don't think it matters. Okay, so the total number of possible outcomes is 1, 2, 3, 4. So this is my sample space. This is my sample size. This is how many total possible outcomes I have. So what is the probability of rolling a tails and then a tails? Or what is the probability of a tail and a tail? Well, right here, I have one instance where I can roll a tails and a tails. So the probability of rolling 2 tails is 1 out of 4. There's 4 total possible options in my sample size, and 1 occurrence of rolling 2 tails in a row there. So that's 0.25 or 25%. Here it says, what is the probability of rolling 2 heads? Well, here's a head and a head. There's only one of them again, so the probability of rolling head and then head is 1 out of 4. Again, or 0.25 or 25%. So there's a 25% chance of rolling 2 heads. And I'm going to edit this question right here. It says, what is the probability of HT? I'm going to change this to what is the probability of rolling a head and a tail. So notice here I have a head and a tail. Here I have a head and a tail. So there are 2 ways, if you flip 2 coins, to get a head and a tail. So that would be 2 possibilities, 2 options for rolling a head and a tail divided by 4 total possible outcomes. 2 divided by 4 can reduce to 1/2, which is 0.5 or 50%. So the probability of rolling a head and a tail in whatever order is 0.5, 1/2, or 50%. And that's everything for this lesson, combining set notation with probability. Hopefully now you're able to find the probability of an event happening in both fraction, decimal, and percentage form. Hopefully now you understand a little bit more what probability means, what we're finding when we're finding the probability of something. And hopefully you can find probabilities of events given in set notation, like in probability of intersections and probability of unions, like we saw on some of those examples. So I hope that was helpful. Please reach out to me if you have any questions, and I hope you enjoyed that as much as I did.